Hello and welcome to our first video for our series of DMA 30. My name is Dane Peterson. I'm a success coach with the College Success Center. I'm going to be guiding you through the curriculum that we're going to be viewing in DMA 30. This section of DMA focuses on rates, ratios, percents, proportions, and unit conversions. And today we're going to start our talk on section 3.1, rates and ratios. This first video is going to focus on ratios. We're going to define what a ratio is and talk about how we write it with different types of notations. Then we'll move on to equivalent ratios, simplifying ratios, and then we'll do a little bit of converting units to write a proper ratio. In the next video that we cover for this section, we're going to focus on rates. We'll define rates and how to write them, and then we'll look at unit rates and unit prices. Alright, let's start with ratios. First we'll start with a definition. A ratio is a quotient of two numbers or two quantities that have the same units. That's really important. Same units. We'll see that if something has different units, that's going to be called a rate. But ratios are always going to have equal units. So we'll compare feet to feet, or inches to inches, pounds to pounds, kilos to kilos. It's always going to be two quantities that have the same unit. Let's remember real quick what the word quotient means right here. Quotient is the answer to a division problem. So these are going to typically be represented as fractions, but we'll see in this example that they can be written in several different ways. So in this example here, let's write the ratio of 2 to 3 as a phrase with a colon and as a fraction. We can write ratios three different ways. So first let's start as a phrase. We can pick that phrase right out from the problem here. We're going to use the word 2 to define a ratio here. So we could write this ratio as the ratio of 2 to 3. Okay. Next they ask us to write a colon. Alright, so with a colon, the first number that we'll write the first number that we see, 2, then put a colon in there to the number 3. And that's just read just like the phrase, the ratio of 2 to 3. And last but not least, we're going to write it as a fraction. We'll put the first number that we see as the numerator. On top, we'll have the 2, and the denominator on the bottom is going to be the second number that we see, 3. So that's three different ways that we can write the same ratio. As a phrase, here, with a colon, or as a fraction. And it's important to note that when we write a ratio as a fraction, we always want to express it in lowest terms. So we're going to want to simplify those fractions as much as possible. The ratio of 2 to 3 is already simplified because 2 and 3 don't have any common factors to factor out, so this is already simplified. Next, let's talk about equivalent ratios, or we sometimes call these equal ratios. Equivalent ratios are two ratios that represent the same number. Okay, so they're simplified or they're expanded upon to represent the same number. So in this example here, we want to write two different equivalent ratios for the given ratio 5 to 10. So let's start by representing that ratio as a fraction. We've got the number 5 over 10. Okay, and one way to write an equivalent ratio would be to divide out a common factor. We know that 5 and 10 are both divisible by 5, so we can divide the top by 5, okay, and we can divide the bottom by 5, okay, and we get the ratio 1 to 2. Okay. These ratios are equivalent because they both represent the same number 1/2. If we did 5 divided by 10, we'd get 0.5, and 1 divided by 2, we'd get 0.5. A second way to write an equivalent ratio would be to multiply the top and bottom by the same number. So if we start with that same ratio given, 5 over 10, and we multiply the top and the bottom by the same number, let's say we multiply them both by 2, okay, we'll get the ratio 10 to 20. Again, this ratio 10 to 20 represents 1/2. If we did 10 divided by 20, we'd get the decimal 0.5. So this is a second form of the equivalent ratio 5 to 10. And we could write several different ratios equivalent to this by multiplying by common factors. If we multiplied by 3, we get 15 to 30, which is also equivalent. 4 would be 20 to 40, also represents 1/2. So there are many different ways. There's an infinite number of ways to write the same ratio with an equivalent ratio. Now let's look at an example where we'll simplify a ratio. Remember, when we write a ratio as a fraction, we always want to represent it in lowest terms. So the dimensions of a garden here measure 10 feet by 24 feet. The units are the same, okay, so we know that this is going to be a ratio. Good. We want to express the ratio of these measurements as a fraction in lowest terms. Okay, so let's start by writing this as a fraction as is. We have 10 feet over 24 feet. Okay, and the units are the same, so we'll say that they cancel out. We're not going to express this with a unit because it's a ratio. The unit feet divided by feet is going to cancel each other out. Okay, so we're left with a ratio of 10 to 24. Okay, but now we need to express this ratio in its lowest terms. We notice that the top and the bottom are going to have a common factor of 2. They're both even, so we can divide the top by 2, and we can divide the bottom by 2. Okay. And 10 divided by 2 is 5, 24 divided by 2 is 12, and this ratio is now in lowest terms. 5 and 12 don't have any common factors. Nothing else can be simplified out of this fraction. So this ratio in lowest terms is going to be 5/12. Next, let's work on simplifying a ratio of decimals. So we want to write the ratio of 3/10 to 1 2/10 as a fraction in the simplest form. Alright, so let's start by writing the numbers that we have as a fraction. 0.3 over 1.2. Alright, and we don't want to have decimals in a ratio as lowest terms. So let's start by getting rid of the decimal. To get rid of the decimals here, we're going to multiply the top and bottom by the same number. Okay, but what number are we going to use to get rid of these decimals? Well, we're going to look at the decimals and we're going to see what the place value is of the last number in each column. This is in the tenths place, and this is also in the tenths place. So if we multiply by 10, we'll get rid of those decimals. If we had something in the hundredths place, we might multiply the top and bottom by 100. Or if we had something in the thousandths place, we would multiply the top and the bottom by 1,000. But in this case, both of our numbers terminate or end with a digit in the tenths place, so all we need to multiply by is 10. When we multiply the top by 10, we're going to get 3. We multiply the bottom by 10, we'll get 12. So far so good. We got rid of our decimals and we have whole numbers now. Fantastic. But this still isn't in lowest terms. We're going to have to divide by a common factor. The top and the bottom are both divisible by 3. So we're going to divide both of those by 3. 3 divided by 3 is 1. And 12 divided by 3 is 4. So we get this ratio of 1/4, which is a fraction simplified to lowest terms. Now let's look at something a little bit more complex. We're going to work at simplifying ratios of mixed numbers. So here we have the ratio of 4 2/3 to 1 1/6, and we're going to write this as a fraction in simplest form. So let's start by writing this. This is going to look a little weird at first. It's 4 2/3 over 1 1/6. Again, a ratio in simplest terms is going to be a whole number on the top and a whole number on the bottom. So we're going to have to do some work to get to that place. Let's start by writing these mixed numbers as improper fractions. So 4 times 3 is going to be 12, plus 2 is 14. So we're going to write that as 14 over 3 divided by that fraction bar. 6 times 1 is 6, plus 1 is 7, 7 6. So now we have two improper fractions. We've got an improper fraction here, and we've got an improper fraction here on the bottom. So what's going on here? This is a fraction divided by another fraction. We can perform that fractional division by multiplying by the reciprocal or the flipped fraction of the bottom. That's going to look like we keep the top fraction, 14 over 3. We change the division to multiplication, and then we flip the bottom fraction here. Instead of 7 over 6, we take the reciprocal of 6 over 7. Right? So now we have a fraction times a fraction. I'm going to take out the common factors in this step because it's going to make life a little easier for me than multiplying across the top and then multiplying across the bottom and then getting big numbers to simplify. I can take common factors out of the top and bottom now. So I see that 3 and 6 both have a common factor of 3. I'm going to divide 3 by 3 and get 1. Divide 6 by 3 and get 2. And I see that 7 and 14 have a common factor of 7. I'm going to divide the 7 by 7 and get 1. And I'm going to divide the 14 by 7 and get 2. And at this point, I've factored out all my common factors. Now, I'm going to multiply across the top and then multiply across the bottom. When I multiply across the top, 2 times 2 is going to give me 4. And then when I multiply across the bottom, I'm going to get 1 times 1, or 1. So now I have the ratio of 4 to 1. And I'm going to leave it as a fraction like this. We know that 4 divided by 1 would be the whole number 4. But since we're writing a ratio, and we need to express that as a fraction, as a comparison of two numbers, we'll leave it like this, 4 over 1. We'll see soon when we do unit ratios, unit rates in the next section, we would write this as a whole number, but since this is a ratio, we have to compare two numbers together. We'll leave it as 4 over 1. The last thing that we'll talk about in this video is converting units to write ratios, not rations, excuse my typo there, ratios, not rations. Remember from our definitions earlier, a ratio has to have the same unit. So when we're asked here to write the ratio of 12 inches to 2 feet as a fraction in simplest form, we've got a problem here. We've got two different units, inches and feet. So we can do conversions to make these the same unit and then write a proper ratio. So we're going to do this two different ways. First, let's start with the ratio 12 inches to 2 feet. Okay, so we've got inches and feet. We need to convert one of these to get the units equal so they'll cancel out like they did in the earlier example. In this one, I'm going to start by converting inches to feet. To go from inches to feet, I'll divide by 12. Okay, so I divide the number of inches by 12 because there are 12 inches in 1 foot. Okay, and that gives me 1 foot to 2 feet. This is good. Our units are the same, they'll cancel out, and we'll get the ratio of 1 to 2. Conversely, I could have converted the feet to inches. Let's see what that would look like. If I started again with 12 inches to 2 feet, I can multiply the feet by 12 to get that feet in inches. When I do that, I still have 12 inches on the top, and then 24 inches on the bottom. My units cancel out, and I'll get the ratio of 12 to 24. And now I have to put this in simplest terms. I'll divide by the common factor of 12, and I'll get the ratio of 1 to 2. Just like I did last time. So it doesn't matter which you convert, the top or the bottom, you'll still get the same answer once you simplify completely. If you want to make things a little easier on yourself, if we can take things from big to small like we did here instead of from small to big, That'll prevent us from having to do unnecessary simplification later, but really it doesn't matter. Whichever way you go, you're going to get the same answer. So to review, in this video we talked about ratios. We defined them. We talked about different ways to notate them. We talked about equivalent ratios, simplifying ratios to lowest terms, and then sometimes converting units to write a proper ratio. In the next video, we'll cover rates. So we'll define rates and talk about how to write them, and then we'll talk about unit rates and unit prices. So I hope you enjoyed this first video, and we'll see you next time.